Right, hello, Year 12. This is the University Grade Prediction Exam, Paper 1. This is the Mechanics and DC Electric Circuits paper. Right, marks were on the whole, or for most of you, lower in this than the paper 2. The reason is the topics themselves are not more difficult. It's just exam questions much more often with mechanics and electricity are using in unfamiliar situations. They pretty much always involve application of the knowledge and understanding to something you have to think about, something you have to look at and go, right, what is going on here? Which parts of the topic is this question on about? Okay, so that's, I believe, or we believe, the reason why students in Year 12 struggle more with mechanics and electricity. In Year 13, it balances out because by then you've had a lot more practice, like I said, applying knowledge and understanding to unfamiliar situations. But the bottom line is it's reading a question, looking at an exam question, and recognizing as quickly as possible which direction to go. Okay, so with these two topics, exam questions are a little bit more outside the box. With waves and materials, I'm sure you'll agree, when you look at a question, it's kind of immediately obvious which direction the question wants you to go in. For example, if it's a standing waves question, it's pretty obvious, even from the diagram, which direction you need to go in. Okay, so anyway, let's get started. Which question 1? Yeah, let's go for question 1. Right, vectors and scalars. Okay, you should know these. This is a question that should be like, bang. This should take the amount of time it takes you to read 8 words to get the right answer. Okay, it's as simple as that. No excuses here, guys. Acceleration is obviously a vector. Mass is a scalar. Distance is a scalar. It's displacement that's the vector. Speed is a scalar. It's velocity that's the vector. Energy is a scalar. Force is a vector. Displacement and momentum are both vectors. Momentum sometimes catches people out. Momentum is a vector quantity. It has direction. And you should be able to see that from the equation P equals mv, p being momentum, of course, right? Velocity is what v is, which is a vector. Mass is a scalar. Now, in maths, if you multiply a scalar and a vector, it always comes out as a vector quantity. Okay, so the answer is D. Right, question 2. This was marked incorrectly. Unfortunately, for the whole of the cohort, which is interesting because the vast majority, I think almost all of you, went for A, but that's not the right answer. Even though it's probably marked, even though it's marked correctly, okay? Because this involves just saying, okay, force equals mass of the rocket times its acceleration. There is a trick here. Okay, there's something. This is not as straightforward. The equation, Newton's second law equation, is sigma F equals ma. What's sigma F? Sigma F is the resultant force. Okay, this F you're trying to calculate is not the resultant force. Why? What is the resultant force? Okay, it tells us that the rocket is accelerating vertically upwards from the surface of the Earth. So if we draw a little sketch, you always draw a sketch, even with the simplest questions, especially in mechanics, got to go for a sketch, okay? Right, so what forces have we got? Well, we've got the thrust, but what else is there? Weight. There's the weight of the rocket going vertically downwards. Okay? So, delta F now is T minus mg equals mass times acceleration. So T minus mg is the resultant force. So we've got values we can put in. We've got the mass, which is 12,000. 12,000 times 9.81. That's the weight of the rocket. That's equal to mass of the rocket, 12,000, multiplied by its acceleration, which is 1.4. Okay, so that comes out with a value of t, that one there. Okay, so I've gone through all the papers. I've remarked this specific question. Interestingly, almost all of you lost a mark because almost all of you went for A. Okay, but two of you went for the correct answer, C. So two of you have actually gained a mark here. Okay, I'm not going to say who the two students are, but Mohammed and Hannah will be very happy that they've got up a mark here. Okay, right. Question 3. Okay, this is where your recall of the defining equations in electricity is crucial. I really don't want to see anyone looking through their formula sheet to try and remember the equations for electrical power, the defining equation for current, and so on. You really shouldn't be doing it. This should be bang, bang, bang. Right, so what do we got here? Mobile phone, constant power of 200 milliwatts. We've got an amount of charge. We've got an amount of voltage. Right, we want the time. So what do we got? Okay, equations wise, right, electrical power, P equals IV. Well, we know I is Q over T. So P equals Q over T times V. Right, we know the power, we know the charge, we know the voltage, we need time. So it looks like that time is the only unknown here. So we've got 200 milliwatts. So 200, just write it down like this. Milli is 10 to the minus 3. I'm going to leave it like that. I'm not going to try and figure out, is it 2 to the 10, 10 to the minus 1, or what? Just write that down. Your calculator's fine with that, okay? So 200 times 10 to the minus 3 equals, the charge is 9400 over time, multiplied by the voltage, which is 3.7. Okay, rearranging that gives a time of, gives a time of 173,900 seconds. But we want it in hours, so we just divide by 60 and then divide by 60 again. It comes out as 48.3 hours. So your correct answer is B. Question 4. Right, this question. Okay, I don't know why students always struggle with two different cylinders in series with each other. Right, it's asking, we've got two cylinders. They're made of the same material. Okay, they're connected in series. Those two facts tell us, well, if it's the same material, it's going to have the same resistivity, isn't it? Because remember, resistivity is a quantity for a material. It's like Young modulus. It's independent of the dimensions of the conductor. It's only specific to the material. Okay, so resistivity is going to be the same. Now, if it's connected in series, the current is the same. Now, this always catches people out, but try and get into the habit. This is what we go back. This goes back to what I said before, of looking at a question and recognizing, right, if you've got two things in series with each other in a circuit, a light bulb should go on in your head, immediately saying same current. Okay, if anything's in series, the current through each is always the same. Even if this is a piece of copper and this is a piece of plastic, the current will be the same. Okay, so same current, same resistivity. Okay, same current, same resistivity, which is B. B. Makes sense? Right, question 5. Momentum. Okay, momentum. Good railway truck. Again, just drawing little sketches, little simple sketches is really important with mechanics, but with collisions, it's absolutely essential, I believe. Right, so what do we got? We've got 2,000 traveling at 1.5. I'm not going to write the units here, sorry. Someone will come in and shout at me, I'm sure. 2,000 traveling at 1.5 hits a stationary 3,000. Now they stick together. They stick together because it says they move off together. Okay? So when they've stuck together, we've got the 2,000 and the 3,000 moving off at a certain speed v. So there we have before and after. So we've got 2,000, 3,000 moving off together. I could have done with a bit of space for the working out here, but so what's the speed v? Well, the initial momentum is due to that, and the final momentum is due to that. So we've got 2,000 times 1.5 equals, well, the total mass is 5,000 times v. Okay, so that gives us a v of 0.6 meters per second. Okay, so it's got to be A or B, but which one? Right, kinetic energy. Kinetic energy is only conserved in elastic collisions. You will only see no change in kinetic energy in a purely elastic collision. Now, elastic, you should be able. You should have an understanding that if you have an elastic collision, things bounce. Okay. Now, if something sticks together, it's an extremely inelastic collision. So kinetic energy must go down. So the answer is A. Okay. So that required a cheeky little momentum calculation, but also an understanding that if things stick together, then we lose kinetic energy. Okay. If things stick together, it's an inelastic collision. Okay. Right. Question 6. Okay, so yeah, it's base quantities, derived quantities, right, and units, of course. Right, which of the statements about physical quantity is correct? Current is derived. No, that's a base. Okay, the volt is a base unit. No, the volt is a derived unit. Coulomb is a base. Yes, interestingly, a lot of physicists believe that the Coulomb should be a base unit. But it's not true. It's the amp that's the base unit. So power is a derived quantity. Of course it is. Okay. Question 7. Right. Thermistors. This is a negative temperature coefficient. What does negative temperature coefficient mean? It means that when temperature goes well, let's get in sync with the question. When the temperature is increased, right? So if it's NTC, when the temperature goes up, the resistance goes down of the thermistor. Okay. If the resistance of the thermistor goes down, the voltage across the thermistor must also go down. If the resistance of the thermistor goes down, the total resistance in the circuit goes down. If the total resistance in the circuit goes down, the total current in the circuit must go up. Right. Okay, it's really important. You look at a circuit like that, just map out what's happening with the quantities. Yeah? And then you shouldn't really be able to, you shouldn't go wrong. So it's saying, which table shows how the quantities change? So what do we got? Reading on V1. that goes down, doesn't it? So we've got to be here or here. Reading on V2. Well, if V1 goes down because it's a potential divider, V2 must go up. Okay. Hang on, I'll start again. Right, V1. Reading on V1 it decreases, doesn't it? So on A or B. Okay. If V1 goes down, V2 must go up because it's a potential divider. And the reading on the ammeter also goes up. We knew that as well. Anyway, didn't we? Okay, so the answer is A. Okay. Question 8. Almost there. Oof. Okay. Is that worth 7 marks already? Not really, is it? Right. Base units. But moment of a force. Moment. Okay, you should be really, really, really good at this by now. Write out the equation. Moment equals force times perpendicular distance from the pivot. Okay, so the units of moment are newtons times meters. Is the newton a base unit? No, it's not. But force equals mass times acceleration. So kg ms to the minus 2 multiplied by meters. And then tidying up, we've got kilograms m squared s to the minus 2. The answer is B. Okay, question 9. Question nine. What have we got? Yeah, it's components of a force. No, components of a vector, in this case, which is velocity. Right? The resultant velocity is this one here. 0.5 meters per second. Okay, that's the resultant. It's given as the vertical component, vertically upwards, which is 0.3. So, if you remember your vector triangles, if this is the resultant, we must have, okay, a different color. We must have a vertical component of 0.3 and a horizontal component of something we're trying to figure out. Now, if the resultant is 5, the vertical is 4. Now, okay, it's a 3, 4, 5 triangle, isn't it? You should have just spotted that. That's what this was actually 0.4, 0.5, 0.3. Okay. You could have done this. You could have done the calculation using Pythagoras, but that question was designed for those with mathematical knowledge of 3, 4, 5 triangles. Okay, because you should know that in maths, if you have a right-angled triangle, if that's 3, that's 4, then that's 5. Done it the wrong way around, haven't I? Okay, that's 3. That's 4. Okay. So it's a 3, 4, 5 triangle. So the horizontal component is 0.4, which is answer C. Finally, question 10. Question 10. Right? Gravitational field strength is, well, the equation is gravitational field strength is force per unit mass. You should know that because weight equals mass times gravitational field strength. So it's force per unit mass. It's A. Thank you very much. That's the multiple choice. Okay.